First three sections are down in Chapter 6. We have Section 4 and Section 5 to go before we get to our Chapter 6 test. And then we'll do the rest of the chapter afterward. Chapter 6, Section 4, we are dealing with rational exponents. And in this section, we are going to use your power table a lot. The main idea here is switching between rational exponents. And remember, a rational number is a number that can be written as a fraction, where we're switching between rational exponents and radical expressions. So our main idea here is that if you have the nth root of x to some power, and we'll call this, we'll just say we have to the first power here. We also could rewrite that as x to the 1 over n power. And this n over x to the first power, it doesn't really matter where that exponent is. We could also write it as n over x, or the nth root of x, all to the first power like this, and they all mean the same thing. Seeing something written in this form is typically a little bit easier to work with, and you'll see that as we go through this section. So for example, if I had the cube root of x to the second power, I could also write that as x to the 2/3 power. And just kind of in general, whatever our fraction is, the denominator tells us the root. In this case, it was the cube root. And the numerator tells us the power. So the 3 is our root, the 2 is our power. Okay, let's do a couple examples. And I'm going to do 3 examples in this one video, and then I'll do those similar 3 problems in the next video as well. So example 1a here, we want to simplify. And first we'll do 625 to the 1/4 power. Now sure, we could type this into our calculator if we wanted to and figure out what that was. You can use rational exponents on your calculator, but of course we're not going to do that. We're going to use the meaning of our rational exponent instead. So switching this to a radical form is going to make this a lot easier to think about and what it means. The top number tells us our power. The bottom number tells us our root. So we have the 4th root of 625, and that's all to the first power. Here's where your power table comes in. If I look at my power table, let's see if 625 is some number to the 4th power. So our 4th powers are here. Scroll down, and hey, 625 is there. That's 5 to the 4th power. And kind of the same idea as before, as far as plus and minus goes. That 1/4, since that power is already there, our root is really already there, and that implies that we just care about the positive. So 5 would be our answer. Okay, next one. If I had 12 to the 1/2 power times 12 to the 1/2 power, we could do this 2 different ways. I have the same base to an exponent. And remember your exponent properties. If you have the same base, we can add those exponents together to simplify. 12 to the 1/2 plus 1/2 would be first. We get 12. Or we also could think about what this means as radicals. 12 to the 1/2 power. The denominator tells us our root, so it's the square root of 12 to the first power, times the same thing here, square root of 12 to the first power. The square root of 12 times the square root of 12 we know is either the square root of 144, if you want to take that middle step, or a lot of you guys just know, hey, that's 12. Okay, what about something like this, where we have 12 to the 1/3 power times 18 to the 1/3. We can't really use our same trick here that we did before because we have different bases. If you look at our powers though, both of these are to the something over 3 power. They're both the 1/3 power in this case, which means if you think about what that is as a radical, these are really both cube roots. 12 to the 1/3 power is the cube root of 12 to the first times the cube root of 18 to the first. And since our indexes are the same, we can take 12 times 18 and get the cube root of 216. Well, let's see if we can simplify this at all. Go back to our power table. We have cube root, so we want to look in our end of the third column. 216, let's see, that is a perfect cube, 6 cubed. So 6 is our final answer.